Alright, so today we're going to start talking about complex zeros and fundamental theorem of algebra. So fundamental theorem of algebra just basically says polynomial of degree n is greater than 0 has n complex zeros. Some of these zeros may... Last chapter we talked about something called multiplicity, which is just the number of times a zero or factor is repeated. Today we're going to start talking about complex conjugates. So if a plus bi is equal to x, then I also have a factor of a minus bi, which is called the conjugate, is also a 0. We're going to start talking about something called the factor theorem. So it says if c is a 0, then x minus c is a factor, and vice versa. And then factors of a polynomial with real coefficients. Every polynomial function with real coefficients can be written as product of linear factors and irreducible quadratic factors, each with real coefficients. So an irreducible quadratic factor is a quadratic with no real solutions. So you'd have two complex solutions. Complex just means, hey, I'm going to be dealing with something with i's. That's all that means. Alright, so example 1 says suppose that we have a polynomial function with zeros at x equals -2 and x equals 3 plus I. So what's the minimum degree of this polynomial? Well, up here I said if I have a 0 with a plus bi, where this is going to be a and that 1 out in front of I is going to be b, that means that I also have another 0 of x is equal to 3 minus 1i, or just I. So altogether I have 1, 2, 3 zeros. So since I have 3 zeros, then my degree is also 3. Alright, and if that doesn't make too much sense, okay, let's go back to putting things in factored form. So if c is a 0, well, let's say for this case c is -2, so then x minus -2 is a factor. Alright, so that would just be x plus 2. Alright, likewise, I would have x minus 3 plus I, and I'd also have x minus 3 plus I. Those are all factors. So I've got x minus 3 minus I, and I've got x, and I'm pretty sure I said minus I, but I think I wrote plus, but definitely one of those should have been plus, one of those should have been minus, because those signs change. Alright. The next part says write our polynomial function as a product of linear, irreducible quadratic factors with real coefficients. So real coefficients just means that we are not going to have i's anymore. So the only thing preventing me from having i's right now is this part of my function. So I'm going to go ahead and I'm going to distribute those out. So I'm going to have x minus 3 minus I times x minus 3 plus I, and I'm going to distribute that out. Cool, cool. So then I am going to get x times x, which is going to give me an x squared. I'm going to get x times -3, which is going to give me -3x. Then I'm going to get x times I, which is going to give me just xi. And then I'm going to go to -3 times x, which is just going to give me -3x. I'm going to get -3 times -3, which is +9. And then I'm going to get -3 times I, which is just going to give me 3i. Alright, and then lastly, I'm going to take -i times x, which is going to give me -ix, or -xi. Then I'm going to have -i times -3, which will give me a positive 3i. And then I'm going to have negative I times positive I, which should give me a negative I squared. Alright. And I write it like this just so I kind of see my like terms. All that kind of good deal. Because now I'm just going to add my like terms together. You can write it straight across. I prefer actually starting to write it this way once I get more than just a binomial times a binomial. Trinomials are a little bit more difficult to see like terms. So then I get x squared minus 6x. My xi's are going to cancel out. Plus 9. My 3i's are going to cancel out. Minus I squared. Alright. So I see that I still have an I, but then we remember back to probably algebra 2, where we said, okay, well, I squared is just equal to negative 1. Because again, the square root of negative 1 was equal to I. So therefore, if I squared both sides, then I would find out that negative 1 is equal to I squared. Alright, that's why that is. Okay, so substituting that in for I squared, I would get x squared minus 6x plus 9 minus negative 1, which will just turn into plus 1. So all in all, I'm going to get x squared minus 6x plus 10. Ta-da! Alright, and then on part D on the next page says, write your polynomial function in standard form with your zeros at x equals negative 2, x equals 3 plus I, and we know now that we have a factor of x is equal to 3 minus I as well. Alright. So, I've already distributed the blue part of that particular function. So, in order to get it in standard form, I want it to just be like x cubed plus something x squared plus x plus 4. So I don't want this in factored form at all, but I don't really want to distribute out that blue part again because I've already done it once. So I'm just going to carry that down. So I'm going to have x plus 2 times the quantity of x squared minus 6x plus 10. Okay, so now I'm going to distribute that out. So I'm going to have x cubed times, and then I get negative 6x squared, and then I get 10x. Alright, and then I get 2x squared minus 12x plus 20. Yeah. Alright, so adding my like terms up, I would just get x cubed minus 4x squared minus 2x plus 20. And that should be the end of example 1.